So here is the exercise. So giving the order one, this one is not just order but order one. So you have order ID, order date, product ID, product name, product price, and order quantity. Then from here, this one is a snapshot, or it is called an instance of order one. Okay, snapshot or instance of order one. So you should, the term instance or term snapshot is actually comes from relation schemas literature. Then it just have all the rows and tuples for all the tables there, and following functional dependencies hold. Giving one order ID, you can find only one order date. Giving one product ID, you can find only one product name or one product price. But giving one order ID, you may find more than one product name. Let's say giving order ID, you may find product P1, you may find product P2. Okay, and also giving a product ID, giving a product ID. Let's say product number 1. Okay, you may find 2 orders. Okay, 2 values. So it means that product ID cannot determine order ID, and order ID cannot determine product ID. Okay, but giving one product ID, you can find only one product name, and you can find only one product price. That one is what the product ID means. Okay, then this is given. But then also giving one order ID for one product, you can find only one quantity. So giving one order ID for one product, I can find only one quantity. If giving the same order ID for the same products, I buy 3 more, I should not have the new line. I should just update this one and plus 3 in, which means I should never have this. Which means that order ID and product ID should never be repeated. Okay, should never be repeated. Which means that order ID and product ID can determine order quantity, but that one is what given here. Okay, what is given here. Okay, but giving the order only, ID only, let's say giving the order ID only, you cannot determine quantity because there are 2 of them. Okay, and giving product only, which is product 2, you cannot determine their quantity because it may have 2 or 3 over here. So have to be both of them. Yes, both of them. Okay, so that one is the exercise. Now we'll get to the question. The first one is please perform the following operation. No, you don't have to show the steps, just show the result. You can show the step if you want to. So find the closer order ID, which means all the attributes that order ID can determine. Okay, first order ID can determine order ID for sure. Then order ID given here can determine order date as well. So order date. So what else? You cannot find anything else because order ID cannot determine anything else. It have to be both of them. So order ID can only determine order ID, order date can only determine order date. So you cannot add anything. Okay, so it stopped there. This one is the closer. Next one is find the closer of product ID. So it is product ID plus, it's equal to first product ID can determine product ID itself. Okay, and from here we see product ID can determine product name, can determine product price too. So you can have product name, product price. Okay, so this one will be the closer of it because nothing else. Order ID, product ID only cannot determine quantity. Product ID only cannot determine order. Product ID cannot determine order date. So that one is a closer. Next one, find the closure of both order ID and product ID. So first is have to have order ID and product ID closure. First, it must include order ID can determine order ID, of course, and order ID can determine order date, like from here. So you have order dates. Order ID cannot, but then product ID can determine product ID, of course, and product ID can determine product name. Remove this one up. To remove this one. Product name. This one is name. Okay. Then both of them, order ID and product ID, can determine order quantity. So you put quantity over here. Order quantity. So this one is closer. It includes all of the attribute already: order ID, order date, product ID, product name, order quantity. Product ID can determine product price as well. Product price. So I have to add that too. Okay. So the closure includes all the attributes inside that relation. Next one. Question number 8 is say select correct statements regarding relation. So product ID is a super key. Okay, get back to this one. It is a super key, means it have to determine all the attributes, or its closure includes all the attributes. Okay, so again, it is super key. It is super key if it can determine all attributes, or its closure includes all the attributes. Okay, so again, just that is too important that I have to write. Left hand side or something is a super key is the same as left hand side or some attribute determines all attributes, or it's the same that the left hand side closure of the left hand side equal to all attributes. When I say equals here, I mean it must include all the attributes. So these three are equivalent. So from here, get to the exercise. You see the product ID is a super key. It's not right because product ID cannot determine everything. Product ID can only determine product ID, product name, product price, not the other things. Similarly, order ID can only determine order dates. So it cannot determine everything. So if it cannot determine everything, then it's not their super key. But product ID and order ID is a super key, yes, because it's determine everything. You can see from here, it's determine everything. It includes all. Its closure includes everything. Okay. It is a candidate key, yes, because if you drop one of it, if you drop order ID, product ID cannot determine everything, so it's not the super key. If you drop product ID, order ID cannot determine everything, so it's not super key. So if you drop either one of them, okay, it's not the key anymore. It's not the super key anymore. That's why it is minimal. And the super key and is minimal, then it is a candidate key. So this one is true, this one is true. The last one here, we have only one candidate key, no more. So that's why you have to select one of that to become primary key. That's why this is the primary key. This is also true. Okay, so this one is very, very important. So the next one is, please provide answers for the following one, and you only have to say yes or no. If you say yes, then just say yes. If it's no, then you need to give evidence. So let's say you say order one, satisfying first NF. First NF here means atomic cell values, which means in any cell here, it contains only one value. Okay, so on and so forth. You don't have such thing like P1, P2, P3, three values. Now, you may have multiple values here like day, month, year, but I already said given the order date is atomic, so I consider this as one. I don't split them. So from here, it's satisfying the first NF condition because there is no repetition or there is the atomic cell value for everything. Next one, does the order one satisfy second NF? In order to satisfy second NF, first it must be first NF and no partial dependencies. Partial dependencies. Okay? Of the non-key attribute to the key attribute. Then for sure, is this one pass the condition? We check if this one pass the condition. We see from this that the key is product ID and order ID. Okay? But we also see that, so the key must be order ID and product ID. But you will see that order date depends on only order ID. This one is partial. Okay, product ID determine product name, product price as well. This one is partial. Because the full key must be both, but product name depends only on product ID, which is part of it. Product price depends only on product ID, which is a part of it. Okay, order date depends only on order ID, which is a part of it. So it's not full. So there are two partial functional dependencies there. So you say the second condition here, you say no. And the evidence is you see that there is a partial dependency. Order ID determine order date. It is partial. And product ID determine product name, product price. Okay, it is also partial. So these two are partial. Why partial? Because it depends only on one part of the two. Either one, not have to be two. Why? Because here is a key. Two key have to be two. But this one depend only on one. This one also depend on only one. So it's not second enough. Now the next one is, okay, is it third enough? You will just say no. Okay, why? Because in order to be third enough, it have to be second enough, and no transitive dependencies between the non-key attribute and the key attribute. Non-transitive dependencies. But it's already violate the first one. You just say no because not second normal form. That's it. That is evidence because you're not second normal form up here. That one, you fail that condition, you don't have to check the second condition. So that is no. So next one is, does order one satisfy the BCNF conditions? Say yes or no. This one is a no. Okay, because BCNF definition BCNF, which is say left hand side have to be super key. And again, left hand side is super key, the same as left hand side determine everything or all the columns. Or it also means that left hand side plus include all columns. It have to be for all of the function dependencies. But we see from here that order ID determine order date, and order ID plus not include all attributes, okay, because it's only have order ID and order date. Similarly, product ID determine only product name, okay, and product price, okay, and if you want to add, you can determine product ID as well, product ID here, product ID, but it's not all, okay, it's not all, so it's not super key, it's not determine everything, it's not include all the attributes. If you have the closure, if you say this, you have to add closure, okay, so equal to that, okay, so there are two evidence here. First evidence is this: order ID does not include all, product ID does not include all, okay, so there are two violations. So with that two violation, we move to the next one. We decompose the order 1 into BCNF. For decomposing order 1 into BCNF, we focus on the violation. Let me just erase all of this to take some space, because I put a lot here just to explain in details, but I want to take some space here. So they say for any functional dependencies hold here, okay, left hand closure of the left hand side must include all attribute. So you see that closure of order ID, this one must be order ID, does not include all. So it's first violation. Second violation here, closure of the left hand side. This is closure of the left hand side. Says, okay, include only this, not all. But the third one, closure of that here, it does include all attribute. So this one, no violation. So there are two violations here. So you just write V1, V2 down there. Write them down here. So to decompose that, we start with violation. For any violation, split them. So for V1, you split it out. So you will have order, okay, and that one, actually I should have, that one is R1, and it should have order and order date, okay, and you may have another violations, okay, which is R2, which is from here, another violation V2 for product. So you will have this one, order ID, product ID, product name, product price. So you already given this one is violation 1, this one violation 2, and this one we already know that order ID determine, or just close that of it, won't determine order date, won't hold, because this order ID won't determine order date, hold. This one, order ID, product ID will determine product name, hold, will also determine product price, hold. So what holds in here will be, product ID determine product name, product price, I lazy to write the whole product, so I mean here is product price, P price I mean. Okay, so this one will hold in there. Then whenever you split a table, so this one become, you can nominate a primary key because order ID now, okay, determine everything. Product ID now determine everything inside here because it's super key. Its closure include all the attributes in this relation. Its closure of the order include all the attributes in this relation too. So this one now is primary key, this one now is also primary key. So you underline this and this. Next one, whenever you split the relation, you have the left hand side as primary key, you have to leave a copy of that in the original relation to keep the relationship. So this one is R3. You will have to keep the order ID there, and it is primary key and foreign key too, and you'll have to keep product ID, primary key and foreign key too, and you'll have quantity. And for this, both of them become primary key because I am lacking of some space, because we already have this relationship held order ID and product ID, okay, determine quantity. So you see from here every of the left hand side, so closure of the left hand side will determine everything. For this one, closure of the left hand side will determine everything. For this one, closure of the left hand side will determine everything as well. So all of them becomes BCNF, BCNF, and BCNF. Okay, all three are BCNF, and this one is there. Then the next one, okay, the next one they say, okay, the term is instances. Giving that, okay, giving that instance, you need to split them into 3 instances because you split them into 3 tables already. So right now, what first thing I want to do is to give R1 a more meaningful name, which is order. R2 is actually about the product, so I'll give it product. And R3 is actually order details, so order item, order line, order detail. Let's just give it D. So first you need to split the order. Here I'll have the, let me just start with product. First I have product, and this have product ID, product name, product price. We'll have product ID, product name, product price. So we will have this. You need to split product ID, product name, product price out. So from here we have product ID number 1, P1, 100. So you will have 1, P1, 100. Okay. Then from here we have product number 2, P2, 200. Product number 2, P2, 200. Okay. Next, we have product number 1, P1, 100 again, but this one is duplicated, so we don't have to store. Okay, that's why we save space if we split. Next, we have product number 3, P3, and 300. So down here you have product number 3, P3, 300. Okay, we saved one space for P1 here. Next, we need to have order. And inside order, you have order ID and order date. And order ID and order date, we'll just look up from here. You will have order ID 1. Date is the first day of the year. So order 1, 01, 01, 2021. Okay, you can see from here, same order, same day as well, so we don't have to store it, so we save space. So order 2 on the second days of the year, so see from here, order 2 01 02 2021. I may have the wrong order, okay, but you just look at that. Then you also have order number 3. Okay, yep, still second days of the year, so you have order number 3 01 02 2021. Again, you don't have to repeat for order 1 information, so you save tab. And the order ID here is unique, product ID here is unique, so it's primary key, super key as well. The next one is order details, or order details. You need to know what order ID are there, what product ID are there, and what quantity are there. So it's just, you need to keep the relationship between the product and the order. Okay, what order what products. Okay, and this one, let's say, I need to erase this. There will be no duplication here. For order number 1, product number 1, they buy 2. So order number 1, product number 1, they buy 2. Okay. For order number 1, product number 2, they buy 3. Order number 1, product number 2, they buy 3. Order number 2, product 1, they buy 3. Order number 2, product 1, they buy 3. Then order number 3, product 3, they buy 2. Order number 3, product 3, they buy 2. So it's actually all the tuples of this 3 columns, because there will be no repetitions here, because order ID and product ID will always be unique. So you will not be able to remove any of the repetitions, just like product and order. Okay, so this will be the 3 instances, okay, from there. And believe me, if you wanna get back the original one, you can just join this 3 table, okay, and then you get back to the original one. So this one is a good one, and you don't there is no duplication, so you don't have any issues, and all of them are in BCNF. Okay, and field NF. Okay, so this is that.